Question 11. What is the temperature rise in Kelvin when 504 joules of heat energy are absorbed by 0.110 kilograms of solid iron? Specific heat capacity of iron is 0.448 joules per Kelvin per gram. If I've been given a specific heat capacity, the only equation I know with that is enthalpy change, or Q, equals MC minus MC multiplied by temperature change. So enthalpy change I've got is 504. Okay. Absorbed, so it's a minus value. Minus MC delta T minus MC multiplied by the temperature change, minus 110 grams. So remember, kilograms needs to be in grams. It needs to be in grams for this equation. So I'm going to multiply by 1,000 to get kilograms into a smaller unit. 110 grams. 0.448. 0.448 is my specific heat capacity that I've been given, multiplied by the temperature change. I'm going to multiply these two out now. So minus 504 equals minus 49.28 times temperature change. So temperature change is minus 504 divided by 49.28, which is 10.2. 10.2 is 1.02 times 10 to the power of 1, so the answer is B. Calculate the enthalpy change in kilojoules for the dissociation of 1 mole of propan 1-ol. So 1 mole of propan 1-ol into 3 carbon atoms, 8 hydrogen atoms, and 1 O atom. So you're given the bond dissociation enthalpy, how much energy is needed to break a bond on average, mean. So when they're bonded to different kinds of atoms, then the bond enthalpy changes, but on average, then this is what the value of these bonds are. This is how much energy in kilojoules per mole is needed to break these bonds. So what I've got to do is I've got to work out how many of these bonds are in this, because the enthalpy change, the total enthalpy change, is the number of bonds broken. That costs you energy. You needed to put energy in to do that. Take away the bonds made, that gives you your energy back out, and the overall difference is the enthalpy change. So the bonds broken in propan 1-ol. So propan 1-ol has got 7 carbon to hydrogen bonds. There's 7 H's there. That H is bonded to the O. The other 7 H's are bonded to C's. So 7 carbon to hydrogen bonds. In there I've got a carbon bonded to a carbon bonded to a carbon. So I've got 2 carbon to carbon bonds. I've got a carbon then bonded to an oxygen. So I've got one of those, and I've got an oxygen bonded to a hydrogen. If I add all of those up from these values here, it comes out as 4403. So my bonds broken is 4403. My bonds made is actual 0, because I've not made any bonds. All of these 3 carbon atoms, 8 hydrogen atoms, and 1 O atoms, they're all single atoms. They're not joined to anything else. So my bonds made is 0, so my bonds enthalpy change equals just bonds broken, 4403, take away 0, 4403 is answer C.